We're going to have Thomas presenting in the first half of this meetup, and then he is going to be joined by Sandy Carter, who is the Vice President of Windows and Enterprise Workloads at Amazon Web Services. And we're looking forward very much to having Sandy here with us. But first of all, let's give a round of applause to Thomas.
Hey, thank you. Yeah, hi everybody. Maybe I can encourage some of you to stay. I want to give a little talk about, when we're talking about cloud computing, about serverless computing. We heard already about functions in the talk before, and I want to give you a quick overview what serverless computing actually means, what the difference are in the architecture, and how that all works. Again, my name is Thomas, on Twitter, Thomas Witt. I am with Infopark, and I'm responsible for our content management system, Squiddo, which is a React.js-based CMS. So the title of the talk is basically servers are a thing of the past. So what I mean with that is let's take a quick look at the evolution of data center computing and why serverless computing is relevant for basically all of us. So if you take a look at the different categories you can have when you manage actually stuff on servers, you have this category, not our problem, that is good. You have the category, our problem, and then you have another category where the actual value is created. Let me translate this for you into some examples. So the first thing what you can do is you can run your own data center. That means you have to care for all of this. You have to care for the hardware, you have to care for virtualization, operating system, the runtime, container if you use some, application, and function. That is basically the worst of all you can get. We could also call that NAS, nothing as a service. The next evolution would be actually to take a look into cloud computing and use services like Amazon's EC2 or stuff like that. So they take away basically the burden of managing the hardware and the virtualization. And next thing where the value actually from you is created is the operating system. That would be a typical infrastructure as a service like Amazon, Google, and whatever. But still, you have to care for all that other stuff, like running your application, keeping the containers online, and so on. Next level would be something then where you actually don't care about the containers. There are some servers out there who manage all running your Docker containers or whatever for you, which is basically called container as a service. Still a bit better, but leaves all that application stuff for you. Next level is platform as a service, where all that basically hardware stuff is totally handled by somebody else, and you just deploy your application to somewhere. That is typical example of Google App Engine or stuff like that. But still, you have to care about how you write all your functions. And basically, the stuff where we want to go is we just want to write code and deploy a function who does stuff into the cloud, and that is basically what we call function as a service or serverless computing. If we want to understand that, so serverless computing is function as a service. And to understand that, as some people say, hey, well, serverless computing, wow, but we still have servers, but it's in a way the same like Wi-Fi still has wires somewhere, obviously. But you run these servers, but you actually don't have to manage them. You don't care for it. You just deploy the code somewhere. And that is basically the whole idea of function as a service and serverless computing. And so it's more when you have an idea and want to put it into production, you don't want to care actually about infrastructure. So the first advantage you get is it's much faster. If you take a look at typical deploy times, when you deploy an application, you're first talking about typical stuff like server deployments, which can take months if you need actual servers. Then we talk about cloud deployments, which are a little bit faster, usually have that in days. Containers set up in a couple of minutes, but functional, basically deployed within seconds. So basically, you save a lot of time when you go to that, and also you save a lot of money. That is a very interesting aspect of this whole cloud computing thing, because you actually pay per transaction. So let's take an example. You build an application which is quite under fire, which manages the event for South by Southwest or whatever. And let's say we have about like 1,000 transactions per second on that application. We rent a typical server at Amazon, so that would be something like $5 an hour, which results in about $3,500 for the whole month. And so when you do that, actually you need that 2 times, because you need actually a second server for failover, and then you run your stuff against a Lambda function. And the thing is, if you run that on Lambda, it is actually cheaper already. It doesn't cost you $3,500, but only $1,170. But only as long as your application is under fire. Let's take a look at situation when you actually, the load on your server goes down and you maybe have only 1 transaction per second, and you still pay your double $3,500. But if you have actually serverless computing or a function which is running that, it is basically a couple of bucks only a month, or even less than a buck. So that is the important thing to understand about serverless computing, that we have that still basically here in a table, that the cost is much lower if the application is actually not under fire, and you are not the one who is responsible to actually scale that. You just deliver your function, and the serverless computing service does the rest for you. And if you're still not convinced, it means the cost of an idle system is actually 0. So if your system is not used, you don't pay a single buck. And that's very interesting from a point of financial perspectives. So serverless means basically you don't pay for, if nobody uses it, you don't have to worry about any scaling, because they do that all for you, and you don't need to provision and manage servers, which results in cheaper, faster, more resilient services in the end. So let's take a look at a typical example application. Let's say we are building an application for a superhero. Let's say Mr. Incredible needs an application whenever his help is needed, wherever, for example, here in Austin. A typical application would be you have your users using the web, accessing it through a browser, and goes over the internet, and then hits your server where your actually application is running and where you use that. Maybe you need to maintain the server, you need to maintain a database, and you need to maintain the functionality at all. So in a typical diagram, how that works is you would set up your Incredi app on your server. You need to have some kind of application server if you're running Java or JavaScript or whatever you're doing. And then you need to start setting up firewalls, obviously. You need to set up your UI within the application with whatever technology you're using. You need to set up your app at all, which has all functionality. You need to manage notification services. You need to manage databases and all that kind of stuff. So that's basically what you have to do. And then you need to maintain a database which actually persists all that information and data. That's basically how you build a typical application, which you then deploy on a server. If you take a look at that from a serverless or functionality perspective, it is much more divided into kind of function blocks. So first you have the UI, which would be, for example, written in React.js or something like that. Then you have your user data, where you usually use some kind of existing functionality, whether it may be Auth0 or AWS Cognito or whatever. There are thousands of others which you can actually use. Next thing is you have some kind of an API gateway, so somehow you need to set up your REST interface, which accepts all these calls from React.js and so ever. So there's a service for that as well. And then you would go further and say, okay, I set up my functions, which are really the core of my service, in, for example, AWS Lambda. So what you do is you have all these functions like receive an alert, log that alert, notify the police, get a notification, send that out to the superhero and whatever, update the villain database, all that kind of stuff would be own functions which you then deploy one by one on serverless. And that might be combined with a notification service, for example, Amazon SNS, which automatically takes care of sending out push notifications to mobile phones or text messages or whatever. And that is then managed all within a database, which is usually also a kind of a service like Amazon's DynamoDB, for example. And then you might even have some other third-party services like, for example, our CMS. So you see we are getting from a more monolithic application to a much more functional-oriented concept, how you actually build up your app. And the thing is, most stuff you don't do is you don't build an app. You just create your functions and make use of all the stuff which is already existing within the app. So what basically happens then when you log into that application, you just download your React application, and that then accesses all these services, kind of, we could also call them microservices, in the backend as function as a service. So we are moving away from that one monolithic app, which contains all the business logic, to moving apart all of this logic to the browser. And that is also a very important concept to understand. When you have function as a service compared to others, that we have these functions, which is the only stuff which you actually manage or actually have to maintain. And then you have some stuff which comes from a backend as a service, like the functionality of notifications, the databases and all that stuff. And you have a browser, whatever that is. For example, you use React.js to use in the browser. So what's important to understand is that this plays very well with what we just heard about React.js, because in former times, you basically were using all the functionality of the applications on the server. So, of course, the user management, the database, which is a backend functionality, but basically all your application logics, the flow, the routing, the views, how your application is rendered was on the server, and basically the browser only took care of some like forms validations, animations, and whatever. And that changed a lot when we use React or kind of that stuff as a front end, because that architecture changes because of most of the stuff actually goes into the browser. So the whole functionality of the application is maintained within browsers, and you only access REST APIs in the back end to trigger functions, to trigger serverless computing in the end. So that is a kind of a paradigm shift of how we used to create applications and how we create applications now in the future. And again, this is rock solid. It's just a JX application which is downloaded from some CDN and then accesses these serverless functions. And if you don't call them, you don't pay for them. And that's a very different model of before. And that model is very often called JAMstack. You might have heard about that. That means basically all your applications are based on client-side JavaScript, so the application logic is not anymore on the server. It is mostly in the client and only accesses functions in the back end, which are basically reusable APIs, which you access, for example, through REST interfaces. And they're all based on pre-based markup, so you can basically pre-render everything, put it on a CDN, and download it as needed. So that's basically the browser starts accessing all these back-end functions. So that could be an ERP, your databases, your user management, Twitter, whatever, CRM services, and so on, instead of just having a simple monolithic server, which basically handles everything. So to summarize that in a very short way, you can ask yourself, will it Lambda? Does it have does it based on function? Is it basically serverless computing? If yes, you're already done. Everything's great. You can party. If not, you just have to try a little bit harder and move your stuff to serverless. That's all for me. Just a quick overview of what actually serverless computing is and does, and how that paradigm shifts in the next, I would say, year.